Have you ever tried to draw a perfect circle that hits a few specific dots on a page? I mean, it sounds simple, but it's way harder than it looks, right? Well, it turns out there are some simple geometric rules that make it a piece of cake. In this explainer, we're going to go on a little quest to learn those rules and master the art of the perfect circle.
So, here's our game plan. First, we're going to jump back to basics and talk about what a circle even is. Then, the real fun starts. We'll take on the 1-point challenge, then the 2-point challenge, and finally, the ultimate 3-point challenge. And we'll wrap it all up by seeing how this connects to the super cool world of triangles.
Okay, first things first. Before we can even think about drawing a circle, we have to know its fundamental identity. I mean, what are the two essential pieces of information we absolutely need to have?
That's it, just two things, a center point and the length of its radius. You can think of these as the secret code that unlocks any circle you could ever want to draw. If you know these two things, you're golden.
All right, let's start with our first challenge, and we'll ease into it. If I just give you one single point, a lonely little dot in space, how many circles can we possibly draw that go through it?
So, what do you think? How many circles can we get to pass through this one point? Is it just one? Maybe a dozen? Or more? Take a guess.
The answer is infinite.
Yeah, you heard that right. It sounds kind of wild, but it's absolutely true. An infinite number of circles.
And this image shows you exactly why. See that point A? We can plop the center of our circle down literally anywhere we want, at M1, M2, M3, you name it, and then we just stretch or shrink the radius so that it hits point A. The possibilities are quite literally endless.
Okay, 1 point was easy. Let's ramp up the difficulty a bit. What happens when we add a second point to the mix? Well, this changes everything. We've just left the world of infinite possibilities, and now we have to follow a very strict set of rules.
You know, with 2 points, it all comes down to a really simple comparison. It's like a little battle between the radius of our circle, which we'll call r, and half the distance between our 2 points, AB. If your radius is longer, you get 2 circles. If it's the exact same length, you get 1 perfect circle. But if the radius is shorter, sorry, you get nothing. It's impossible.
Let's see this in action because it makes more sense. So here, the distance between A and B is 3 centimeters. Half of that is 1.5, right? And our radius is 2 centimeters. Well, since 2 is bigger than 1.5, that puts us squarely in 2-circle territory. And boom, there they are, 2 perfect circles, and both of them pass right through A and B.
And that brings us to the final and honestly the most exciting challenge. We've seen infinite circles for 1 point, and then 0, 1, or 2 for 2 points. So what happens when we try to capture 3 points with one single perfect circle?
And here it is, the big reveal. As long as your 3 points don't all fall on a single straight line, which is just a fancy way of saying they're non-collinear, there is one and only one circle that can connect all 3 of them. How cool is that? We went from infinite possibilities all the way down to a single, unique solution. This special, one-of-a-kind circle actually has a name. It's called the circumcircle. And it makes sense, right? Any 3 points that aren't in a line can form a triangle. So the circumcircle is just the circle that perfectly wraps around that triangle, hitting all 3 of its corners. And look, you can see it right here. The points A, B, and C make a triangle, and there's that perfect circumcircle, with its center right at M, hitting every single vertex. It's just a perfect geometric fit. Okay, so we know this unique circle exists. Awesome, but our quest isn't quite over. We still have to find its center. And it turns out the location of that center depends completely on the shape of the triangle that our 3 points create.
So this special center point is called the circumcenter. Now, to find it, you just do this for each side of the triangle. First, you find the exact middle of the side. Then, you draw a line through that midpoint at a perfect 90-degree angle. That line is a perpendicular bisector. And the one single spot where all 3 of those lines cross, that's it. That's your circumcenter.
Now this is where it gets really, really cool. For an acute-angled triangle, where all the angles are less than 90 degrees, the circumcenter is always chilling inside the triangle. For a right-angled triangle, it's sitting exactly on the midpoint of the longest side, the hypotenuse. And get this, for an obtuse triangle where one angle is bigger than 90, the circumcenter is actually outside the triangle itself.
Let's look. On the left, we've got a right-angled triangle, and just like the rule said, the center M is right there on the hypotenuse. Then, on the right, we have an equilateral triangle, which is a kind of acute triangle, and sure enough, the center M is sitting nice and cozy right inside.
And just like that, our quest is complete. We've traveled from infinite possibilities all the way to one unique solution. So now, it's your turn. Grab a compass, grab a ruler, and see if you can draw this triangle and find its unique circumcircle. It's a great way to see for yourself the beautiful hidden order that's all over geometry, where even tricky problems can be solved with just a few elegant rules.